Good afternoon, learners. Today, we're going to explore the amazing world of science, the branch of chemistry. But before we proceed, I have here a picture for us to analyze. Have you ever wondered why sugar and salt are placed together side by side, but always with label? So, this is to prevent the confusion because most of the time, the sugar and salt are being replaced with one another because of their appearance, of their similarity. Now, we have placed these two substances together but without labels. Okay, so napagpalit natin sila, for example, napagpalit natin yung sugar and salt. How do we now identify which one is the salt and which one is the sugar? Do you have any idea? How do you now differentiate one from the other? If you have your answers, kindly type in your answers on the comment box below and I will read it later once I see your answers. Yes, I have seen your answer, Julio Livelo. This is from my advisory class, grade 9 Anang. So, this is from their taste. So, we have to taste. It is easier for us to identify which one is the sugar and which one is the salt by, of course, tasting them. But this method of identifying substances is not applicable to every other substances or to every other compounds because some compounds are toxic or harmful to our bodies. Just like these examples in the picture. Meron tayong mga substances or meron tayong mga compounds that has poison or can cause poison to our body. Just like this one, meron silang mga label na merong X, fire, o kaya naman ay bone. So we have to set distance if we see this kind of labels. Kasi ang ibig sabihin yan, they are toxic or they are harmful to our body. Last week, we have discussed the electron configuration. So to have a recap, let's have this example. So we have here Fe. I hope you have with you your periodic table of elements. Now, I want you to type in on the comment section, what is the element name for Fe? Okay, so I'm looking right now at the comment box. Again, if you have your answers, what is the element name for Fe? All right, you are correct. Fe is the element name for Fe is iron. So iron is an element that belongs to the periodic table of elements in the classification of metals. Now, the first thing that we need to do in solving or in answering electron configuration is to identify its atomic number. Now, grade 9, I want you to look at your periodic table and determine what is the atomic number of iron. So there are comments below. Yes, that is 26. Again, thank you so much, Julio, for being the first one to answer my question. We have also Natalie Cesar, Janelle Brioso, Kylie Reberiano, Jasmine Namahan, and the other students. So, very active ang ating mga students. So, again, the atomic number for iron or Fe is 26. After we have identified the atomic number for the given element, we have to distribute the electrons via electron configuration. So when we do electron configuration, we have to follow a certain method. And that is to follow this series, the 1s, 2s, 2p, 3s, and so on. For element Fe or iron, we have here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Okay? So when we add all the exponents here, we will arrive at number 26, a total number of 26, which is the atomic number of iron. Now, we will add another idea, which is the valence electron. This is very essential to our discussion this afternoon. How do we get the valence electron? This is how you get it. First thing that you need to do is to identify where is the outermost energy level. And for us to identify the outermost energy level, we have to look at the numerical coefficient or the electron shell. Here in the example, we have the electron shell 1, 2, 3, and 4. Okay? So, since valence electron is pertaining to the outermost electron, we have to, of course, identify what is the outermost shell. Usually, it is the greatest number in the series. In this series, we have 4 as the greatest number, meaning to say, this is our valence shell. So again, our valence shell is 4. Now, how many electrons does this valence shell have? Ilan yung electron na kayang i-hold ng valence shell 4? Again, if you have your answers, please type in on the comment box. How many electrons does valence shell number 4 can hold? So I'll be looking at the comment section for your answer. So we have here the first one to answer, John Gabriel Durian. So you are correct. It is 2. The valence shell number 4 contains or can hold 2 electrons. So meaning to say, our valence electron here is 2. Okay? Do you follow grade 9 students? If you follow, please type in yes. Okay, so I see answers. Yes, thank you so much, grade 9, for your cooperation. And this just means that I can now move on from this recap. Everyone is seeking stability. Okay, when we talk about stability, we are referring to the strength or resistance to chemical change or physical disintegration. If we humans are seeking stability, so was atoms. And atoms, when they talk about stability, they are referring to the involvement of possession of 8 electrons in their outermost shell or outermost energy level. So they have to contain or they have to have 8 electrons on their valence shell for them to be said to be stable. Now, atom of all elements, therefore, again, for them to become stable, they have to contain 8 electrons or 8 valence electrons. That is for their stability. Okay? I have here a simple activity. This is for you to answer. But before we proceed, if an element is following this 8 valence electron possession, it is considering the octet rule. So, sinusunod niya yung rule na to. Ang sinasabi sa octet rule, electrons should be 8. Dapat 8 yung electrons sa valence shell ng isang element para maging stable siya. Okay? So again, I have this activity for you to do. A very simple task lang naman ito. You have to identify or determine the valence electron of the following elements. So we have Ne, neon, Ar, argon, and Kr, krypton. Now, the first thing that you need to do, of course, is to have with you your periodic table of elements and then find these elements Ne, Ar, and Kr. Then you have to identify its valence electron through answering or through electron configuration. So, kailangan nyo siyang i-solve via electron configuration. So, using your knowledge with electron configuration. So, you can type in your answers with or in the comment section. How many valence electron do we have for Ne, Ar, and Kr? And I would like to ask the assistance of Sir John Velas to check the comment section kung meron na pong mga sagot ang ating learners for this simple activity.
Yan. So, ma'am, good afternoon po.
Good afternoon,
so, our learners are still figuring out the answers. And
yes,
there are no answers yet.
They should do electron configuration first. So, we have, sir, answers na ba? Meron na
yes, from Julio Livelo, I guess. Sabi niya, for neon, his answer is 6. The valence electrons for the element neon is 6.
Okay. So, let's wait for the other, sir.
Okay po.
Again, let's have the steps. First is to identify the given atomic number for each element, and then conduct your knowledge or use your knowledge about electron configuration to answer or identify the valence electron of the given elements here, Ne, Ar, and Kr. Sir, do we have any answers na po?
Yes po, ma'am. We have from Norin Garado, 8 for argon. From Justin Pong, then Singh, he said we have 8 valence electrons for argon.
Okay, so most of them are answering 8. So if your answer is 8, thank you, Sir John, you are correct. Okay, the valence electron for Ne or neon is 8, Ar argon is also 8, and Kr krypton is also 8. Okay, so these 3 elements have the same number of valence electron. And if you're going to look at your periodic table, again, I hope you have with you your periodic table of elements. You can find these 3 elements on the rightmost part of the table. And if you have your, if you're going to look back on your grade 8 class, this was discussed and they belong to the noble gas family. The noble gas family is said to be stable. Okay? Dahil nga 8, yung kanilang valence electron, they are following the octet rule. So, sumusunod sila sa ating octet rule, which means these 3 elements together with the rest of the elements involved or considering their family, the noble gases, they are all stable. They are all stable elements. Next, so to discuss further, let's have our objectives. Number 1 is to recognize the different types of compounds from their properties, such as melting point, boiling point, hardness, moldability, ductility, volatility, solubility, and conductivity. Number 2 is to explain the formation of ionic and covalent compounds. And lastly, number 3 is to explain the properties of metals in terms of their structure. So this is your task. You have to have with you these three essential things. Your periodic table, because we'll be using this all throughout the lesson, a copy of your module for reference, and of course, pen and paper to take down notes. Okay, so I guess you have with you these three essential things. Then, let's proceed with our first activity. So, yung kanina ay our ano lang siya, a warm-up activity lang siya. So, this one is our first activity, entitled, Which Element Creates a Perfect Match? Okay, so for this activity, you must be holding your periodic table as I discussed the instructions that you need to follow. For this activity, you just have to answer this question. How many valence electrons are needed for elements to make a perfect match? Okay, to answer this, you have to pick one element on the green column and one element on the red column. So, any of your choice dito po sa tatlong element sa green at sa tatlong element dito sa red. Any combination yung pwede ninyong makuha or pwede ninyong piliin. Then, after that, you will now identify the valence electron. Let's say, for example, I pick Li or lithium for the green column with the valence electron of 1, and I pick Cl or chlorine from the red column with the valence electron of 7. Then the next thing that you need to do is to add or get the total number of valence electron. So 1 plus 7, that is 8. So again, after we have gathered the total number of valence electron, you have to chat or type in your answers on the comment box such that I can see your progress. I can see your answers. Okay, so I'll be waiting for your answers in the comment section below. Just type in the total number of valence electron and which element did you pick or choose. You just have to follow this format. Again, valence electron nung dalawang element na pinik nyo from green and red column. And then, the total number of valence electron. So, I just want to answer the question here. Let's go back first such that you can follow thoroughly. Let's say, for example, the valence electron here, or the valence shell rather, is 3. So, we have 2 3s here. Meron tayong dalawang 3. Dalawang shell na 3. Meaning to say, ipag-add nyo po yung electrons that they have. Okay? Ayan. So, I hope I have answered the question, Mr. Livelo. Okay, so I see now answers from Natalie Cesar, K or potassium, and F, fluorine. So we have electron 8. Very good. Janelle Brioso, sodium and A, and chlorine, Cl. Total valence electron 8. Same with Christian Decena, K, potassium, Br, bromine. We have total number of electrons 8. Valence electron 8. Okay, so that's it. Okay? Yun na yung pinaka-sense nung activity. That is for you to identify a perfect match for each element for them to become stable. The question now, how will you compare the first activity that we did with this 3 and our second activity? How will you compare what did you do or kung ano yung mga ginawa nyo from the first activity, again, here, for NE, AR, and Krypton, to our second set of activity. Again, if you have your answers, you can type in on the comment section. Just a comparison, just a little comparison between the two set of activities. For the first set of activity, kinailangan ba ng kapartner nung ating mga elements? How about the second activity? What do we do? Okay, so I see now answers from, again, Natalie Cesar. Yung una pong activity, isang element lang po. Sa pangalawa naman po na activity, may dalawang element. Okay, so you have the correct answer. The first set of activity, ang pinakita natin doon, there are elements that are said to be stable. Sabi ko nga kanina, because they belong to the noble gas family with a valence electron of 8, which means they are following the octet rule and they are stable. For the rest of the element, kagaya ng ginawa natin sa second activity, nagkaroon tayo ng pairing. Hinanapan natin ng ka-match yung ating mga elements for them to achieve stability. Kailangan nila ng iba pang element for them to be stable. Okay, it is possible, but how do they do this? How do the elements bond with another element for them to become stable? Okay, that is through our topic this afternoon, chemical bonding. So, through chemical bonding, nagiging possible yung pagkakaroon ng stability for the other elements na hindi belong or hindi part ng noble gas family. When we talk about chemical bonding, we are pertaining to compounds. Nagkakaroon tayo ng involvement of compounds. We have compounds like, for example, water. In this one, we have H2O. Compounds are formed between the chemical combinations of two or more elements. Let's say again, for example, we have 2 hydrogen atoms plus 1 oxygen atom. If they undergo a certain process or a certain chemical bonding process, they would become a compound with the name H2O. Or in layman's term, this is water. Okay? So may mga pahabol pa tayong answers sa questions. You are correct. Okay, so same answers with the first one. Thank you so much, John Gabriel Durian. Thank you so much for the participation. You are correct. Again, when we talk about chemical bonding, we are involving compounds. So again, for example, we have 2 hydrogen atoms plus 1 atom of oxygen. If they undergo a certain process or chemical bonding, they would produce H2O compound or water in layman's term. Alright, so let's have now the two types of chemical bonding. We have ionic bonding and the covalent bonding. When we talk about ionic bonding, it pertains to an interaction between, again, two elements, but this time it involves one metal and one non-metal element. So you have to be reminded na kapag pinag-uusapan natin ay ionic bonding, ang magkakaroon lamang po ng interaction with one another is one metal and another element which is a non-metal. So metal to non-metal. And this is possible by the transferring of electrons. Again, sa mga subatomic particles, we have protons, neutrons, and electrons. Ang nagpa-participate lang sa lahat ng activity ng isang atom is the electron. Kasi siya yung freely flowing or siya yung nakaka-move sa part ng mga subatomic particles. Hindi kagaya ng proton and neutron na nandoon lang sa loob ng nucleus. So again, we are transferring electrons through bonding or what we call the ionic bonding. On the other hand, when we talk about covalent bonding, this exists between two non-metal elements or one metalloids and one non-metal. So yun yung classifications natin when we undergo or when elements undergo covalent bonding. And it is possible to happen instead of transferring, nagkakaroon po tayo ng sharing of electrons. So again, instead of transferring electrons, under covalent bonding, they will now share electrons. Before we proceed with the discussion of these two processes, you have to be familiarized with the periodic table of elements, asan ang mga metals, non-metals, and the metalloids. In this example, or in this picture of the periodic table of elements, most of the elements ay color pink, right? Most of them are pink, and they are said to be metals. Then we have on the rightmost part, color blue. These are known to be nonmetals together with hydrogen. And this ladder-like structure here is the metalloids that separates the metals and the non-metals. So, titignan lang po natin dito yung sa ating legend and yung placement ng ating mga elements for us to be able to identify what type of element yung tinutukoy or yung given if we have a given set of problems. At this point, we'll be talking about the ionic bonding or ionic bond. Again, when we talk about ionic bonding, we are pertaining to the transfer of electrons. So, nagkakaroon tayo ng transferring of electrons. Specifically, ang tawag po sa mga nag-transfer or nagpa-participate na electrons during any process is called the valence electron, yung nasa outermost shell. Kaya sabi ko kanina, it is very important na maging familiar po kayo on how to identify or determine the valence electron of each element. So this one, let's say for example, we have atom 1, which is a metal, and atom 2, which is a non-metal. Nagkaroon sila ng chemical bonding undergoing ionic bond. So one electron will be transferred to the other one for this atom, atom number 2, to become stable. As you can see, meron lamang siyang 2, 4, 6, 7. 7 valence electron. Remember that if we are seeking stability, if atoms are seeking stability, they have to have 8 valence electron. And for that to happen, they will undergo a certain process. In this example, ionic bonding. So para maging stable siya, kailangan nyo pa ng isa. Kailangan nyo pa ng isang electron, which will be given off by atom number 1. So nagkakaroon tayo ng, again, transfer of electron. So this reactants will yield to this product. Naging stable na yung atom number 2 kasi nabigyan na siya or nakapag-transfer na ng isa pang electron, which means meron na siyang 2, 4, 6, 8. 8 valence electron, and this atom is now stable. Okay? So let's have an example. We have here sodium or Na and chlorine atom or Cl. The first thing that we need to do is to identify the atomic number of these two participating elements. Now, grade 9, what is the atomic number of Na and Cl respectively? If you have your answers, please type in on the comment box. Again, what is the atomic number of Na and Cl? So I'll be looking at the chat box to see if you have your answers for the question. You can always refer to your periodic table of elements. Okay, let's wait for a moment. The atomic number of Na and Cl according to, again, very active Natalie Cesar, Na is 11 and Cl is 17. Same with Andrea Bacolcol Awaaw. So Na is 11, correct? And then the other participating students, we have Julio, Diane Shane, Jim Rex, you are all correct. Angela Lois, thank you. Ruth, and ayan. So, nag-aangatan na po yung comment section. So, you are all correct. Your answers are Na is 11 and Cl is 17. After we have identified the atomic number of the given element, we are now to distribute the electrons via electron configuration. As you can see in my example, nilagay ko na po dito yung electron configuration for Na and Cl. For Na, we have 1s2, 2s2, 2p6, 3s1. For Cl, we have 1s2, 2s2, 2p6, 3s2, and then 3p5. Okay. Now, in identifying the valence electron, which is the third step, we have to find the outermost shell or the valence shell. For Na, we have 3 with an electron of 1, a valence electron rather of 1. For Cl, we have the valence shell, of course, that is 3 with a valence electron of 2 plus 5 is 7. So basically, if you write down this on our example, the pink circle here, yung pink dot, that is the one for Na, yun yung kanyang valence electron. And then for Cl, yung outermost part niya, meron siyang 2, 4, 6, 7. Yung color blue na dots sa pinaka-outer part shell. So basically, si Na, meron siyang excess na 1, meron siyang excess na 1 electron, and then si Cl, yung chlorine atom, it needs 1 more electron for it to become stable. So, instead of Na gathering or kukuha siya ng 8 pang electron, it would be easier for sodium atom to become stable if i-give off niya yung nag-iisang electron dito sa kanyang valence shell, which is transferring to the chlorine atom. So, yung chlorine atom, makaka-receive siya ng isang electron from the sodium atom, which yields to this picture. Dito na po tayo sa right part ng example, wherein the Na sodium or the Na atom is now stable because it has 8 valence electron. And for the chlorine, ito po yung na-transfer na atom, meron na siyang 8. 2, 4, 6, 8. Therefore, both of them become stable. Okay? So, do you get it? Do you still following the discussion? Are you still with me? If yes, or kung nakakasunod po, please type in yes to the comment section. Again, if you are following the discussion, please type in yes. Thank you so much, Ashley Joyce. So, remember that chemical bonding happens between two participating elements because they are seeking stability. They need to become stable. They need to have 8 valence electrons. So thank you so much, grade 9 learners, for the participation. So this just means that I can now proceed with the next example. Again, they are to seek stability. They have to have 8 valence electrons. Kaya sila nag-undergo ng chemical bonding. So example number 2, we have magnesium oxide. Magnesium, atomic number of magnesium is, will you please type in what is the atomic number of magnesium? You can always refer on your periodic table of elements, as well as for the oxygen. What is their atomic number for Mg or magnesium and O, oxygen? You can type in your answers on the comment section. Okay, thank you so much. For magnesium, you are correct. That is 12. We have the first one to answer, Julio, followed by Marco, Jarina again, John Gabriel, and many grade 9 students. So, for Mg or magnesium, we have 12. 12 yung kanyang atomic number. And for oxygen, we have 8. Again, the next thing to do is to distribute the electrons via or using the chemical electron configuration rather. So 1s2 for Mg, 1s2, 2s2, 2p6, and 3s2. For oxygen, we have 1s2, 2s2, 2p4. Okay? Then, the next thing to do is to identify the valence shell, outermost. Okay? So, for Mg, that is 3. And for oxygen, that is 2. And then, identify kung ilang electrons yung na-hold nung valence shell. For Mg, we have 2. Therefore, the valence electron for Mg is 2. For oxygen, we have 6. 2 plus 4 is 6. Therefore, the valence electron of oxygen is 6. Putting it in a diagram, ganito po yung magiging itsura niya. So, the valence electron of Mg here, we have 2. And then for oxygen, we have 2, 4, 5, 6. So, meron siyang 6 na valence electron. Of course, again, seeking stability, following the octet rule, they have to have 8 valence electron to be stable. So, ito transfer ng Mg or ng magnesium atom yung dalawang electron niya to the oxygen atom for them both to become stable. For Mg, dahil na-transfer na niya yung dalawang electrons sa oxygen atom, magkakaroon na siya ngayon ng 8 valence electron. 2, 4, 6, 8. Therefore, stable. For oxygen atom, since it received the 2 electrons from the magnesium, it would have 2, 4, 6, 8. 8 valence electron, therefore, stable. Okay? So those are just some of the examples of elements that undergoes ionic bonding for them to become stable. And this one is their applications or uses. Kasi kapag nagkaroon tayo ng combination of elements, they will form compounds. Compounds that are useful to our everyday lives. Like for example, Na and Cl, if they undergo chemical bonding, they will produce salt or yung table salt, which is very useful sa ating pagluluto, preservatives, and any other substances na ginagamit natin in our everyday lives. Okay? Next, we have the sodium nitrite. This is an additive for meat preservation. Usually, ito po ay makikita sa mga frozen goods. Yung hot dogs, tocino, tsaka yung mga ham. Okay? And then the last example here of the application or uses of ionic compounds is aluminum chloride, which is used in deodorants. So as you can see, very important that we know how these ionic compounds are formed because we are seeing them every day. We are using them every day. Okay? So let's proceed to the next type of bonding, which is the covalent bond. Covalent bond, instead of transferring electrons, elements that undergoes covalent bonding shares. Okay? They are sharing electrons. So two participating elements would share their electrons for them to become stable. Okay? So we have two types of covalent bonding. We have the polar and the non-polar bond. As for example, again, instead of transferring, uulitin ko po, we are sharing electrons here under covalent bond. So let's say, for example, we have this two participating element. So we have atom 1 and atom 2. Remember that when we talk about covalent bond, this has to be one nonmetal or two nonmetal elements, two nonmetals or one nonmetal and a metalloid. So I will repeat, two nonmetals or one nonmetal and one metalloid. So they can undergo covalent bonding. So instead of transferring their electrons, they will share, just like this one in the picture. They will share this electron such that they will become stable. For letter A, since they share with letter B, or atom 1 and atom 2, kung anong meron sa share ng atom 2, contained na rin siya ng atom 1. Same with atom 1, kung ano yung na-participate niyang electron at na-share niya sa atom 2, kay atom 2 na rin yun. So, ang bilang na niya magiging 2, 4, 6, 8. Kasi nag-share na sila sa part na ito. For atom 2, 2, 4, 6, 8. Therefore, they are now stable. Let's have this example. This is for the chlorine gas or Cl2. Chlorine, just like for our discussion a while ago, its atomic number is 17. So that's the first step. We need to identify its atomic number, of course, using our periodic table of elements. So the atomic number of chlorine is 17. Then after identifying the atomic number, we have to perform the electron configuration. That is 1s2, 2s2, 2p6, 3s2, and then 3p5. Okay? After that, the third step is to identify the valence shell. In this example, the valence shell here is 3. Fourth step, how many electrons does the outermost shell here contains? Ilang electrons yung ino-hold ng ating outermost shell? Again, in this example, we have 5 plus 2. Kasi meron tayong dalawang 3. So you have to add. 2 plus 5 is 7. Therefore, our valence electron for the chlorine atom is 7. So meron tayong dalawang participating chlorine atom with a valence electron of 7. Para silang 7. So instead of transferring, they will share. Magkakaroon sila ng sharing of electrons. So magiging ganito na yung itsura niya after undergoing covalent bond. So 2, 4, 6, 8. This is the part na nag-share na po sila ng kanilang mga valence electron. Okay, so I see answers on the chat box. So we have 7. You are correct. The valence electron of the chlorine atom is 7. Thank you. So both of them, meron silang 7. So they will share para magkaroon sila ng 8. 2, 4, 6, 8. 2, 4, 6, 8. Therefore, both of them, after undergoing covalent bond, is now stable. Okay? Example number 2, same with this. Oxygen gas, we have O2, two participating oxygen atom with an atomic number of 8. Second step is to perform electron configuration, that is 1s2, 2s2, and 2p4. Third step is to identify the outermost shell or the valence shell, that is 2 in this example. And then you will now add the exponents, or these are electrons. So we have 2 plus 4 is 6. Okay? In the diagram, we have 2, 4, 5, and then 6. So, kulang siya ng dalawa para mag-gain niya yung 8 na stability. So, ang gagawin niya, they will undergo covalent bond, sharing of electrons for them to become stable, just like in this part of the picture. Stable na sila dito. How? Because they have now shared some of their electrons. So, naging 8 na yung kanilang valence electron through covalent bonding. That is 2, 4, 6, 8. 2, 4, 6, 8. Both of them now has 8 valence electron, therefore stable. Okay, so you see, all elements, for them to become stable, they have to follow the octet rule. Lagi na lang dapat i-follow yung octet rule. And for them to seek stability, they undergo a certain process. It's either ionic bonding or covalent bonding. All right, so these are some of the examples of compounds that undergoes or after undergoing covalent bonding. So nakakabuo tayo ng water or H2O. We have diamond and rubber. Okay, these are some of the practical applications or uses ng mga elements after undergoing covalent bonding. So, nagagamit naman natin talaga yung iba dyan, especially water. Hindi tayo, we can't live without water. And yung mga rubber, for manufacturing purposes, nakikita din natin yung uses of rubber. And of course, diamond, this is one of the hardest substance in the world. Usually for luxury or jewelry, we are using them. Okay, so these are, again, some of the applications or uses of a covalent compound. All right, we're down to the last part of the lesson for this afternoon. This one is to compare ionic bonding and covalent bonding. So aside from the type of bonding that they have, di ba sabi natin kanina, for ionic bonding, they are to transfer electrons. And for covalent bond, they have to share electrons. Other than that, meron pa tayong mga basis for comparison. Let's say, for example, existence. We have number 1, existence. Ionic bond exists in solid state only. Lagi lang siyang, napuproduce niya is solid. That's why, ang example natin kanina dyan ay salt and yung mga additives na ginagamit natin for preservation. So, most of them are solid. Next is for the covalent bond. For the covalent bond, they can exist in all types of matter, solid, liquid, and gas. Like for example, we have water, which is a solid, right? We have the diamond, that is solid. Water is liquid rather, and diamond is solid. Yung rubber, pwede rin siyang maging type or partly liquid. And for gases, nakita natin kanina example, we have the oxygen gas and the chlorine gas. Okay? So this one, ionic bonding happens only between non-metal and a metal element. Covalent between two non-metals or one non-metal and a metalloid. Alright? Conductivity, when we talk about conductivity, it is a property of an object that allows the passing through of electric charge or heat through them. For ionic bond, low yung kanyang conductivity, meaning to say, hindi siya basta nakakapag-pass through ng electric charge or heat doon sa substance na nabuo under ionic bonding. For covalent bond naman, very low conductivity, which means hindi rin siya basta-basta nakakapag-allow ng passing through of charges or heat through them. Okay? So, in hardness naman, when in terms of hardness, a hardness is the resistance of a material in deformation. So, hindi siya basta-basta nade-deform. Hindi siya basta-basta nagkakaroon ng crack or nababago yung kanyang shape. For ionic bond, they are hard because of their crystalline nature. Like for example, yung mga salt. Yung mga asin, they are crystalline in appearance, which means hindi sila basta-basta nagkakaroon ng change in shape. And for covalent bond, these are not very hard because as for example, we have water, we have rubber. Pero exception, yung diamond. Because as we know, diamond is very hard. So, hindi siya basta-basta nade-deform. So, again, exception po natin yung diamond as well as carbon. For the melting and boiling points, ionic bonding or ionic bond has a high melting and boiling point. For covalent bond, they have low. Ang ibig sabihin lang nito, mas mabilis magkaroon ng, mas mabilis ma-achieve ng covalent bonding or ng covalent compounds yung kanilang melting at boiling point. On the other hand, ionic bonding naman, yung mga ionic compounds, masyadong mataas yung kanilang boiling point and melting point. So, hindi agad sila nagme-melt, hindi agad sila nag-boil. Next is malleability. Malleability is the part where substances are being hammered or pressed into thin sheets. So, for ionic bond and covalent bond, both of them are non-malleable. Okay? Ductility, both ionic bonding or both ionic bond or ionic compounds and covalent compounds are non-ductile. Ductility is the capacity of an object to undergo a change in physical form without breaking it. So, hindi dapat sila basta-basta nag-break into pieces. So, ating pong ionic bond and covalent bond are non-ductile. Volatility has something to do with the melting and the boiling point. Remember that ionic compounds or ionic bond has a high melting and boiling points. So kapag mataas yung boiling point ng isang ionic compound, hindi agad siya makakapag-produce ng vapor. Therefore, ang volatility niya is low. This one. And for covalent compounds, since its boiling point is low, therefore, mas mabilis siyang makapag-produce ng vapor at a normal rate. So that is why its volatility is high. Okay? In terms of solubility, of course, when we talk about solubility, this is the process of which a material or a substance is being soluble in water. Nagkakaroon tayo ng dissolving of a material sa water or sa iba pang mga things or mga liquid examples wherein they can dissolve a material. So for ionic bonding or ionic bond, they are usually soluble in water. So nakakapag nadi-dissolve sila rather sa water, pero insoluble or hindi sila basta-basta natutunaw in organic solvent. In example, ionic bonding, basic example na na-discuss natin is salt. Salt can be dissolved in water, right? So, na-dissolve natin yung mga ionic bond sa water. Pero, they can't be dissolved or insoluble sila pagdating sa ibang organic solvent. Unlike covalent compounds or covalent bond, kapag nag-undergo ng covalent bond, the materials or the compounds are soluble in organic solvents. So, example, yung ether, alcohol, and benzene. Pero, hindi sila basta-basta nadi-dissolve sa water. Example, kagaya kanina, we have rubber. Yung rubber, hindi po siya basta-basta madi-dissolve sa water. Hindi siya pwedeng ma-dissolve sa water. So, yun yung pinaka-basic example na pwede nating i-align with this statement. Again, for solubility, ionic bonds can be dissolved in water, can be soluble in water, pero insoluble pagdating sa organic solvent. For covalent bonding, they are soluble in organic solvent but insoluble in water. So, meaning to say, magkabaliktad po sila. Okay? Uh, do you follow grade 9? If you can follow po, please type in yes sa ating chat box or sa comment box. So I can see if some of you can follow or most of you are following still with the discussion. Type in yes if you can still follow our discussion this afternoon. Okay, I see responses. Thank you so much. Thank you. Okay, let's proceed with table number 3. For table number 3, this pertains to the melting and the boiling point of the ionic bonding. I have a question for you. What can you observe when it comes to the melting and boiling point of this ionic compounds? Is it high or low? Please type in your answers on the chat box or the comment box below. Is it high or low? Okay, I see responses now. We have very active Julio. His answer is high. Same with Natalie, Fausto, Janelle, Christian, Ashley, Job, Andrea, John Gabriel, Romel, and the rest of the grade 9 learners. Most of you, your answers are high. Very good. Remember that ionic bonding has a high melting and boiling point. So what does this mean? Anong ibig sabihin ng high melting and boiling point? Ang ibig sabihin lang nun, a lot of heat energy is needed. Mas kailangan natin ng mas madaming amount of heat energy for us to break the strong ionic bond between or during melting point and the boiling point. So, in effect, nagkakaroon tayo ng low volatility. Again, when it comes to the melting and boiling point, we need to have a lot of heat energy. Kailangan ng maraming amount of heat energy to break the bond or the ionic bond during melting and boiling point. That is why nagiging mataas yung number or yung degree ng boiling and melting point ng mga ionic compounds. In return or in effect, nagkakaroon tayo ng low volatility. How about for the covalent bonding? What can you say about its melting and boiling points? Is it high or low? This is for, again, covalent bonding. Okay, please type in your answers on the comment section. I see answers now. Thank you so much for the response. Natalie, Janelle, Bernadette, Job, Mon, Andre, Eliza, Christian, Reljan, and the rest of the grade 9 learners. Your answers are correct because your answers is low. So you are correct with the response. When we talk about covalent bonding, again, as per discussion a while ago, their melting and boiling points are low. So, ibig sabihin lang po nun, we only need a small amount of heat to break the intermolecular force of attraction between a covalent bonding. So, kailangan lang natin ng small amount of heat energy para ma-break natin yung kanilang bonding. Okay? Para ma-break natin yung intermolecular force within them. In return, or in effect, nagkakaroon tayo ng high chances or high amount of volatility. Ibig sabihin po, mas mabilis makapag-produce ng vapor or nagiging faster yung pag-produce ng vapor or yung boiling point, mas mabilis siya na-reach kapag covalent bonding or covalent compound yung ating pinakukuluan at mas mabilis naman siyang matutunaw if it is a covalent compound. Okay. So at this juncture, you have to answer these two questions. Very simple lang po. And I would like to ask the assistance of Sir John for this part. We
Yes po,
have
ma'am.
letter A. Thank you, sir. So for letter A, what are the commonly used chemical compounds at home? Ano ba yung mga examples of chemical compounds that we can see inside our houses? Or based on our examples, can you give me at least one example and then type in on the chat box?
The students are still answering.
Okay, they're still answering. So, based on our discussion a while ago, nagkakaroon na tayo ng idea kung ano pa yung mga examples ng mga chemical compounds na madalas nating makita or madalas nating magamit. So, we have
John Gabriel Dorian and Ashley Joyce.
okay.
Then we have Julio Livelo, sugar, and Ryle. From Diane Shane Caselo, water. Jasmine Fong is salt, and John Alvin Agoto, sugar. Ruth Madeline Blato, salt, and Natalie Cesar, water. Yun po. Sugar and salt, yung mga kadalasan po nila.
Okay, thank you, Sir John. So, most of them are answering salt, sugar, as I see, and many other compounds, water. These are the substances that we are very aware of. Kilala natin or alam natin yung kanilang mga appearance because we commonly use this at home. So these are products of chemical compounds or these are products of chemical bonding. These are the chemical compounds. For letter B, how is it important for everyone to understand this topic? Bakit ba natin kailangan i-discuss yung chemical bonding? Why do we have to learn this topic? How is it important for everyone? If you have your answers or idea, again, you can type in your answers on the comment section. Because we don't study something for nothing, right? Laging meron siyang importance. Especially kung ang pinag-aaralan natin ay nagagamit natin in everyday life. So kahit keyword or very simple sentence or phrase is good or okay na po iyon, you can just type in your answers on the comment section. How it is important for everyone to understand the topic.
Okay, ma'am, we have an answer from us.
Yes,
Ashley
sir.
Joyce Alonso. It is important to learn this topic because we can learn more about things we usually see or use at home. Then
Okay.
from Diane Shane Paselo, para po maintindihan na po na maigi. From Andrea Bacolcol, it is very important to be aware on the appearance of one chemical compounds. And from Julio Libelo, ma'am, is to be aware of how things around us are made.
Okay, thank you so much, Sir John. So your answers are very acceptable. Lahat naman ay tama, right? Kasi lahat naman yan ay for realization purposes. So it is important for everyone to study this topic, especially yung products niya ay nakasurround sa atin. Lagi tayong nakatingin sa kanila. We are using them. Like for example, yung mga binigay niyo kanina, salt, water, we have the rubber, sugar, and yung mga napoproduce pa. Like for example, mga chemical compounds that are, of course, may be harmful or useful to our body. So it is important for us to know their composition such that malalaman natin how to distance ourselves kung hanggang saan lang yung limitations ng paggamit sa kanila and to understand their true usage. Like for example, yung mga preservatives natin, nagkakaroon lang tayo ng idea sa mismong product na. Yung mga tocino, hot dogs, pero the thing is, paano sila napapreserve ng ganun katagal? So now we have the knowledge that they are using chemical compounds. Okay, so every grade 9 learners are still answering. So we have Natalie Cesar, thank you so much. Jasmine Pong, to be able to learn more fascinating things about things in our everyday life. Thank you so much, Fausto. It's important for everyone to understand the topic so we know what is toxic to our bodies and what are not. Thank you so much for our responses, grade 9 learners. Now we're down to the last part of our lesson this afternoon. So I have here your learning task number 1. Match the definition in column A with the correct terms in column B. Of course, hindi natin siya ima-match. Instead, you will write down your answers on the comment section. So you just write 1, then the letter of your answer, 2, letter of your answer, hanggang number 5. Number 1, the capacity to undergo a change of physical form without breaking. Number 2, the resistance of a material to deformation of an intender of specific size and shape under a known load. Number 3, occurs between metals and non-metals. Number 4, the measure of the ease at which an electric charge or heat can pass through a material. And number 5, last, a property referring to the ability for a given substance, the solute, to dissolve in a solvent. So number 1,
Number 1 daw,
the
ma'am,
correct
is
answer
letter C.
is yes, sir. So we have their answers as letter C. Very good. So number 1 is letter C, ductility, the capacity to undergo a change of physical form without breaking. How
Yes,
about
ma'am.
number 2, sir? Do you have any answer?
Yes, we have number 2, letter G.
Number 2 is letter G. That is hardness.
G,
Very
ma'am.
good, grade 9 learners. How about sir, number 3? May nagsasagot na po ba ng number
Number 3,
3?
ma'am, is letter from Julio Levelo, ma'am, letter F daw po. Then from Marga Arroyo, number 3 daw po is letter F.
Okay, so number 3 is letter F, ionic bond. It happens between metals and non-metals. Number 4 is, do we have any answers? Okay, we
From
have,
Fausto Esguera,
yes.
we have 4 is letter B, ma'am. Letter B daw po, ma'am.
Yes, correct. Number 4 is letter B, conductivity. And lastly, number 5 is letter
B, as in dog.
Number 5 is letter D. You're right. So tama yan, sir. Letter D, yung number 5. That is solubility. Thank you so much, Sir John. Thank you, grade 9 students. So the answers, number 1 is C, ductility. Number 2 is G, hardness. 3 is F, ionic bond. 4 is B, conductivity. And number 5 is letter D, solubility. So you are all correct. Thank you so much, grade 9 learners. And before we end our lesson for this day, I want to leave with you. I want to leave this simple quotation. The world is beautiful outside when there is stability inside. So maraming salamat po, grade 9 learners. And I hope may mga natutunan po kayo sa hapon na ito with regards to our topic, chemical bonding. Thank you so much, grade 9.